Hi everyone, let's talk about soil creep or heave. These two terms are interchangeable and they're talking about how your soil particles individually move down slope over a large area. So let's draw a slope, just a simple one like this. You can draw like a triangle if you want. But it wants you to focus on one soil particle. So we just draw one particle here. And this is what occurs, guys. You either have freezing, wetting, or heating. Freezing expands by 9%. Wetting, you might cause your slope to swell up, your clays to swell up, any soil to swell up. Heating, it just causes expansion. This causes it to expand perpendicularly to the soil surface, so it expands outwards like this. If you want to know why, it's because other soil surrounding it is also expanding. So it wants to expand in the path of least resistance, and that is the air where there's empty space and it can expand. If it wants to expand left, right, down, it's really hard because it's kind of like putting pressure against other soil particles which also want to expand out. So your soil particles expand perpendicular to the soil surface, and after that you may have your thawing of your ice, your drying of the wetted, swollen clays and soil, or your cooling of the temperature. This leads to contraction, and it contracts downwards under the influence of gravity. So it goes vertically down because of gravity. You get this triangle, and you get the net movement, which is downslope like that. So over a period of time, you're gonna get a repeated movement of this, and eventually it'll reach the base of the cliff. I think I'll put the numbers on. 1 and 2 are the same, so this arrow outwards is 1/2. Down is 3/4. You guys can combine it 1 and 2 into 1 and 3 and 4 into 2 if you want. So water content, it depends on what type of expansion and contraction it's doing. It's freezing and thawing, of course you need water. If it's wetting and drying, you need water, but also you don't need water. Heating and cooling, you don't need as much water. So it depends, but generally you need some water. The speed wise, it's really slow. That's why I put so many arrows. As you can see over here, in temperate areas, it only moves 1 to 3 millimeters a year. In tropical areas, it's up to 10 millimeters a year. And in periglacial areas, where the rate is the fastest, it's only up to 300 millimeters a year. So it's really slow, and it's the slowest of all mass movements. Here are the landforms. The first one is terracets. Terracets are kind of like built up soil behind vegetation and stuff. It's like clumped up together. So you kind of get this stuff in your terrain. It's not grass, it's just soil that is like misplaced all around, because this doesn't occur evenly, it doesn't occur like uniformly. It occurs with one soil particle, another soil particle, so it's like really kind of fuzzy shape. Bent trees and fences, because if you have any obstacles like a tree or something, like a tree, like a wall, you get soil built up behind your obstacles, and this built up of soil adds mass, puts pressure onto your trees or fences or whatever, and it starts to push them down a bit. Or if it's like a fence pole or something, like over here, then it will just bend along with the terrain, because it's fixed in the terrain, but the terrain is moving, so it's kind of gonna bend. Exposed roots as well. If you have trees here, you may have roots like that underground, but your soil is moving, right? So if your soil moves and it bends your trees a bit, you might get exposed roots because your soil no longer covers your roots. So those are landforms, everything about soil creep and heave. I hope you guys enjoyed. I'll see you in the next video.